All right, here's the part 3 video for lesson 10.3.2. Promise to keep it short, but we have an important one here to kind of learn the formula NPR, which is pretty much just our permutation formula that we'll see and we can use to calculate these problems. We're going to start here in part A, even though we've already kind of talked about it. In part A of problem 10-122, you calculated how many ways judges could pick that logo contestant winner and 3 runners-up from 52 contestants. And that answer could be written in, I showed this as 52 factorial over 48 factorial, and just a reminder of where those numbers came from. And so we had that really what we did was we did 52 times 51 times 50 times 49 because we had the 4 decisions being made, and it went down each time because we couldn't repeat and that order mattered. And so really what happened there was everything lower than 49, so 48 and down, had to get canceled out. And so what we had was we had the beginning of 52 factorial, so we start on top with 52 factorial, and then we wanted to cancel out everything 48 and less, and so we had 48 factorial on the bottom to cancel out the whole 48 and below. All right? And so really what we're doing there is we're taking our number of choices, 52, because we have 52 contestants to choose from, and we're subtracting 4 because we have 4 decisions being made. And so you'll see that here too in part B. It says the logo contest situation can be thought of as finding the number of possible arrangements of 52 elements arranged 4 at a time. So we're going to re-examine our answers from B and C of problem 122 and use your answers to write them in the general formula to calculate the number of possible arrangements of n objects arranged r times. All right, and so if you look at this formula, it is NPR, N being your number of choices, R being your decisions. And so if we go back, I'm just going to do 1 for time reasons. If we look at part B here, we had the volleyball teams. There were 16 teams, so you had 16 choices in teams, and that they could be organized, or sorry, there could be 7 different decisions being made because you had 1 winner and then 6 other teams, and we wanted to talk about the best top 7. And so what we have there, if we're writing it in terms of NPR, if you're talking about NPR here, we had 16 teams. We had 16 teams to choose from, and so your N is equal to 16, your number of choices per each decision, and then R being your number of decisions. In this case, we had 7 decisions. All right. So if I rewrite this here, this would be 16P7, and then we'll see how to calculate that here in the next one. I guess I'll show it here because why not? What that means is that you would do 16, sorry, that kind of looks funny with that equal sign there. Really what this would be here, it would be 16 factorial over 16 minus 7 factorial. Or if I reduce that down, that's 16 factorial over 9 factorial, which is, if we go back, that's what I actually ended up getting here for that answer for part B. I had 16 factorial over 9 factorial. Again, just coming from, really, it is your number of choices over your number of choices minus the decisions being made. It's a formula that just works for every permutation we do. And so we can start trying to see these problems as NPR problems, doing that the number of choices over the number of choices minus decisions, and just keeping those factorials hooked on there. And we're going to do that with part C here in II, III, or 1, 2, and 3. And starting with C, the first C, if we have CI, the first one, you have 7P4, which would be the same thing as 7 factorial over 7 minus 4 factorial, which gives you 7 factorial over 3 factorial as your answer. All right, for part 2 here, and that's like a problem where it said maybe you had to choose numbers 1 through 7, and it was like a locker combination where you could only choose, or maybe it was like a pin where you could have 4 numbers being chose, so 4 decisions. You could choose those decisions from 1 out of 7, and we would get that 7 factorial over 3 factorial. For this one here, 52P4, so 52 choices permutated over 4 different decisions, you would get 52 factorial over 52 minus 4 factorial, which would give you an answer of 52 factorial over 48 factorial. And then the last one, following the same order we've seen in the first two, you have 16P7. So 16 permuted 7 over 7 decisions, and you would get 16 factorial over 16 minus 7 factorial, which gives you an answer of 16 factorial over 9. Did I do this one already? I feel like I did. Maybe not. Or maybe I did it for this first one here. Yeah, I did 16 over 9 right there. Wow. Okay. And then 16 over 9 factorial. Oops. For your final answer on that one. And that's the kind of problems that you would see when you take advanced algebra. If you already took advanced algebra, if you take it next year, you'll see these permutation problems, and they'll follow that same order. Just remember to find those guidelines. It has to be able to, or it has to say that there is no repetition, and you have to notice that order matters, and you can start doing permutation problems like this. And I'll leave that off here. If you have any questions on permutations, please feel free to email me, or if you're stuck on the homework problem, please email me your questions.